Hey coders, welcome to the channel. So today we are going to implement binary search using Java. So without wasting any more time, let's get started. So now we have this list and let's see that how the binary search implementation will look like. So let's say that we have to find the element 19 from this list. So what we will do is that we will define some variables, and the first variable will be u, and the second variable will be L, and the third variable will be I. So the value of this L will be 0 initially, and the value of this U will be the length of this list minus 1. So let's say small l minus 1. So this will be the value of U. And what will be the value of this I? So the value of this I will be U plus L divided by 2. So this will be the value of I, and let me tell you what this means. So this L means the first element of this list, and this U means the last element of this list. And what this I means, so let's calculate the value of I. So U plus L is 7, and 7 divided by 2 will give us 3, and this 15 is at the index 3 of this list. So this will be the I position of this list. So in binary search, as we know, we search for the first element and see that if that element is equal to the number that we are searching of, and 15 is not equal to 19. And what we know is that 19 is greater than 15, and in the case that we got our element that we are searching of is greater than the element that we have found, then in that case what we will do, we will change the value of this I. So the not that I, it's L. So L will be I plus 1. So I is at 15, so L will be at the 19. So let's erase that L out. So if the value of L changes, then the value of I is also dependent on L. So the value of I will also change. So now let's calculate the new value of I. So now the U is the same, which is 7, and the L has changed from 0 to 3. So 3 plus 7 is 10, and 10 divided by 2 is 5. So this I must be at the 5th position of this list, or at the 5th index of this list, and the 5th index is this 21. So this will be I here, and let me erase out the order I. So now we will do the same process again. We will check that if the element at the I position of the list is equal to the element that we are searching of, and 21 is not equal to 19. So now what we know, that 19 is smaller than this element. And now when we know that the element that we are searching of is smaller than the element that we have got, which is 21, so in that case we will change the value of this U. So the value of this U will be U equals I minus 1. So I is at 21, so this U will be at this 19. So let's write U here, and let's erase that U out. So the value of U will be at 19, and L will also be at 19. So the value of I will also change, and the value of I will also get 19. So let's erase that out. And now we will again check for the element at the L position, not L, it's I, at the I position, and at the I position of the list it is 19, and we got our element which is 19. So the implementation of binary search will look like this. So now let's make our binary search function. So first we will make a main method, so public static void main, and in the main method first we'll make an array of 100 elements. So let's say the array name is int our array equals new int, and let's say it has 100 elements, and let's add 100 elements in this array. So let's say for int I equals 0, not minus 0, 0, avoid this. And now I, while I is smaller than 100 and I plus plus. Now what we will do, we will say out array, it's not out array, let's rename this to our array. Out array at the index I is equals to I. So what this will do, this will add 100 elements to our array, which will be starting from 0 to 99. So this is our array. So now we will define our binary search function. So let's make a method, public static void, let's name the method bin static, and it will take two arguments. The first argument will be integer array, and let's name this arr, and the next argument will be integer argument, which will be val, for which we have to search in this integer array. So now let's define our method. So as we have seen in the explanation, we have to define three variables, and the first variable will be lower bound, so it will be int l equals 0, and the next variable will be int upper bound, which will be equal to the length of this array. So let's say arr dot length, dot length minus 1, so let's say minus 1 here. And now we will have to define one more variable, which is the middle index of this array. So let's say int I equals l plus u divided by 2. We don't have to use floor division here because it is taking value in integer I, so it will not take decimal values. So now what we will do, we have got the middle element or middle index of our array. So now there can be three cases. So let's add a while loop here. While the lower bound is smaller than or equal to the upper bound, and now there can be three cases. If our arrays at the index I equal to the value that we are searching for, and in that case what we will do, we will return I, means the index of where we found the value, and let's add a return here, so int. And now this is one case if the element at the middle of the array is equal to the element that we are searching. So in that case we will return this, the index of that element. And another case will be if array at the index I is smaller than the value that we are searching of. So in that case what we will do, we will change the value of the lower bound, so l equals I plus 1, and we will have to refresh the value of this I, as the value of this I is dependent on the value of the lower bound. So let's copy paste that here, and after that we will add a continue statement here. So what this continue statement does, it takes the executor to the starting of this while loop with these refreshed values, and it is giving an error inti, what it says, navigate to the previous declared. Oh, we have already declared this I, so let's remove this int. And there will be one more case, so let's add else if, and let's say error, and if the element that we have found is greater than the value that we are searching of, so in that case we will change the value of the upper bound. So the upper bound will be I minus 1, and let's refresh the value of this I and say continue again. So let's copy paste this. So these are our three cases, and if this while loop is completed and none of these if our element is not existed in this list, then we will, after this while loop, we will return -1. So our binary search method is complete. So let's minimize this and let's call this method. So let's say bin, and let's pass our array, and let's say we have to search for the element 55 in this array, and 55 must be in our array because it's starting from 0 and ended at 99. So let's print this and let's run the code. And it says 55, so this 55, this 55 that we are searching of is at the index 55 of our array. So let's try for a number which is not present in our array. So let's say 120, and let's run this code. And it says -1 means our element is not in the list, so our binary search function is working. So if you find today's video helpful, then don't forget to like the video, and to get this kind of interesting content regularly, subscribe to the channel, and thank you for watching the video.